Today we are going to look at switch expressions in Java. Switch plays a very important role in organizing the code and handling the uh, logic differently. Even though we have if-else conditions in Java, if the if-else conditions increase quite a lot number, then switch comes to the rescue in improving the code quality. Uh, Yet handling those number of if-else conditions that are possible. So today we are going to look at that. So first of all, let us see what are these if-else conditions that we need to handle. Okay. Let us say so we are passing a string, and if the string, let us say if the string that we have passed is of particular type, for example, if it is equivalent to high, okay, then we are going to just display. Let's say this. Office. Okay, and if we look at any other else conditions, for example, hello. Okay, the string equals hello, then sorry for that. This is a continuous format of this. Okay, so let's say if it is welcome. Else we will just display the program, display the string as is. Okay, if you see here, we have passed a hello, so the next else if condition has applied and then it has displayed. Similarly, if we provide a different string rather than those, then it just displayed the string as is. Okay, so now if at all another condition needs to be added, once again we have to write the else if condition, and in that way we have to add as many number of else if conditions as possible as the condition gets added. Okay, now in such a scenario, okay, if we have to optimize this, okay, to reduce the number of if else conditions that we have to write, okay, what we can do, we will use the switch condition. Okay, sorry. Sorry. Okay, and case, then we need not apply equals or any other conditions, we can just go ahead and display it. Okay, but after the display we'll write a break statement. Similarly for this as well. Okay, we'll write a case, and then break. Similarly for this as well, we'll write a case, Now this will be a default condition, and then we will put it as default. Okay, and then we'll use the switch, and then the. Now if we see, if we follow this off, okay, so here it applies the same condition. However, in here we need not exclusively mention the equals once again, so we will just directly mention it here. Okay, now in this scenario, let us say we can either use these as constants, or with the latest improvements on the switch, we can even write switch conditions. Basically, in general here we cannot this case is nothing but a statement as per earlier versions of Java. So we cannot write any expressions in it, evaluation expressions. Now with the introduction of latest improvements in the pattern matching, okay, and in other improvements, we can write the switch expressions, so that we can even check for the condition, and depending on the condition, okay, against which we can come up with the case statements or case blocks that needs to be applied. Okay, now let us see that. So just switch. Okay, here I would like to try with something called instance of operators, pattern matching. Okay, so in general, if we have to uh, identify the class to which this particular object belongs, then in general we normally use instance of condition, and then further we will write the if conditions, where and if instance of, let us say, integer, right? Then we will write system.out.println of, okay, integer o, integer o. Okay, this is the if condition. Similarly, if there are any number of conditions, we will do that. But for here, for now, we will go with just displaying the object. Okay, see, it has used the dot to string and it just displayed. Okay, however, if I send 10, it will display 100 by evaluating it. So these kind of test switch and test expressions, right? So these are um, here we have to typecast it and then use it, right? So in order this is more cumbersome code which is difficult to maintain. Okay, and it even increases the number of lines of code that we need to write. Okay, and anyways, if o is an instance of integer, then we already know the compiler should be able to identify whether it is identify that this is already an integer, and then let the operation to be performed as is, right? But that is not the case till the earlier Java versions. So with the improvements of the switch expressions, switch pattern matching that have been introduced across various JDK versions, we'll be able to do it using the switch statement with much more ease. So we will see that. Okay, let us see the object one. Uh, switch off O. Okay, and then the case will be let us say if it is an integer I. Okay, now as I mentioned, if it is an integer, then I'll display, right? Similarly, if it is a double, right? Similarly, if it is double, okay. Similarly, double, we'll just display the double, okay. And in case it's a string, okay, we are going to just display string. So we'll write the default, and we'll just display whatever it is present. Okay. Now let us test this switch. Now this switch of 10. So integer is a 10 and it is squared. Now if it is 11.234, so it's a double of 11.234. If we say, if we pass a string, right? See, it has identified that as a string and it displayed the hello value. Similarly, what can we say? Okay, so let us create a record class. Record demo. Okay, and int x comma w y comma string z. Okay, now I will say record r equal to, okay, of 10 comma 0.762 comma, okay. So I have created a record as such. Now if we try to test this against the switch expression that we have created, so it straight away displayed the value system from the system out, okay, in this way. So if you see here, since it is a record has a default to string implement which is already implemented. So it has invoked the dot to string and then it displayed the value. Okay, so this is what it now. If we want to modify it, if we want to modify the conditions, okay, let us say if it is an integer, when integer is less than 10, right? I want to display uh, 10. Okay. Similarly, if I want to consider integer, sorry, let us put it j, integer a, when k is less than 20. Okay, then I would say system dot out dot println of Okay. Now if there is a string and I want to ensure that the string is is length of less, if it is of length less than 10, I want to display it here itself. Okay, if the length is less than 10, then okay. So if you see here, even though we are doing a pattern matching against that, we can still apply some conditions in the way we need. Okay, in the way we see fit. Oh, sorry. Now let us test this. 5 integer with less than 10. So if you see, we passed 5 which is of type integer, but the 5 is less than 10. So the first case statement has case expression has picked it. Now let us say given 50. So 50 is not less than 10. Though it is an integer, it is not less than 10, not less than 20. So we have passed in the third case expression and we have squared it. Okay, and similarly, let us say string, right? Less than 10. Actually, no, no, no. The string is of length 5. Oh, sorry. If you see, the string is of length 5, though it is a string, since it is less than 10. Okay, we are just displaying the length is less than 10. Okay, now however if we add it, okay, then we are just displaying the string in here, right? So in this way we could apply the conditions as well in the switch expressions. So when we want to write complex expressions, right, spanning across multiple object types, switch expressions that we are speaking about now will be of great help. Okay, and along with that, it will even cater to uh, possible values, whether all the possible values of a particular object type are considered or not. Okay, we shall look that example with an enum. Now let us say I have an enum, just enum. Okay, and I would give it as high. Okay, similarly hello, and it is a hello there. Success, success, failure, fail. Okay, now for this one, private string value, private string of string value. Okay, now let us say public string. So we have created the name. Now let us write a new test. Okay, void test switch enum. Okay, and test enums. Okay, No, I am writing a switch expression around this. I would expect this to return a string. Okay. Enums. If it is a case of I, okay, then it will return enums dot get val. Okay. Similarly, if it is a different one, okay, um, it is a little bit different. Okay. Okay. Now let us try to give the value only for these two. Okay, and then try to create the method. Okay. Now if we see here, we have given the required case conditions that we want to test against. Now we got an error. So what does the error say? The switch expression does not cover all possible input values. So ideally it has to take only the input values that we have given. However, since we are passing a specific object type, which is an enum, which has quite a lot number of other values, okay, and which are not covered here. Okay, it has identified that if at all uh, any other type is passed to the method, then it might not process successfully. Okay, so that's where it threw a compilation exception saying that the switch expression that we have written, switch expression that we have written should comply to all the possible values of that particular type to be successfully evaluated. Okay, now let us correct this. Okay, let us say I for now I want to put it as default. um, Name start for now. Okay, see the test switch enum is created. Now let us test this. So see, it has applied and it has written this is a I. Now let us give success. Okay, so here it gave the default value of the success as success. If you see here, these are the default values, and it just give the default value. Okay, now this is a way to handle the unknown types. Okay, however, in such a scenario, okay, even though if we add more enums, okay, if at all we have to write proper implementations against those enums conditions, we will not be able to write them. So it is always advisable to not write a default in such scenarios and implement the case for all possible scenarios. Okay, what are the other possible scenarios that we have? Success and failure. Okay, success, right? And hooray, that's it. Yes, random stop. Okay, similarly failure. Okay, now let us try to create an expression with this and see whether it will compile successfully. So if we see here, it compiled successfully even without a default. The primary reason for that, the enum contained hi, hello, success and failure, all four values. So since it caters to all the possible values in test enum, okay, it has allowed us to succeed. Okay, now to test this, we can test using test switch enum off. test enum dot success. What else is missing? Match exception. Why did the match fail? Why did the match exception fail? Why did this fail? Looks like some compilation issue or something might have happened. So once we some cache issue. So once we modified and created a new method, we can see here that the test enum.success has been applied. Okay, and we can see that this getting displayed. So similarly, if we look at the failure, okay, here also uh, the failure has been applied. Okay, now let us say we wanted to modify the test enum and add another case. Okay, let us say abort. Okay, replaced enum. Now, in this scenario, if we try to compile the same, okay, once again, we will get a compilation exception because we have added a new enum abort, and accordingly, that particular enum has to be implemented in here. So, in a scenarios where if we add any new conditions or text in this way in the enums, okay, then wherever that particular enum is used in all the switch case expressions, it will highlight as a compilation issue, and then accordingly in all those places we will go ahead and make the changes accordingly. Okay, so this will be kind of an alert mechanism where it will tell you where all the data needs to be modified. Okay, so this this is about this. Yeah. So this is about the test switch cases and switch expressions pattern matching that is implemented in the switch